Hello everyone, welcome back to my channel. Once again, we are starting with another question from class 11, chapter 1. So this is exercise question 18. The question states, express the following in scientific notations. So we remember that what are scientific notation? We have to, convert it into the 10 to the powers. All right. So let's take first one. We are taking first one. It is 0.0048. What we have to do? We have to take and shift this decimal after 4. Okay, it becomes 4.8. All right, if decimal is shifted, then obviously it is going to be how many digits we have taken it to shift? 1 2 3. All right, so 3 decimals negative. So the scientific notation for it will be 4.8 into 10 to the power negative 3. All right, let's go to the second one, which is, okay, I'm going to convert. It is in 2,34,000. All right, what we have to do? We have to, there is a decimal which is after these 3 zeros. We have to shift this decimal to 2. Okay, then it becomes 2.34000. You can omit writing 0 also, that is not a problem. Okay, and when we are shifting this decimal over here, then we should once again count 1 2 3 4 5. Okay, we are shifting the decimal to the left hand side, then obviously the power will be in positive, 10 to the power 5, or it can also be written as 2.34 into 10 to the power 5. All right, so this is what its scientific notation is. Once again, next is same. The decimal is after 8. All right, so what we have to do? We have to shift this decimal after the 8 which is on the left side, extreme left. All right, so it becomes 8.008. Once again, we have shifted the decimal to the left hand side from right hand side. The power to the 10 will comes in positive. 1 2 3 3 we have shifted after 3 numbers, so it will be 10 to the power 3. All right, next one. So next one, you can see the decimal is given over here. Okay, this 0 does not have any meaning. So what we are going to do? Once again, decimal is shifted to the left hand side. One non-zero digit should come before decimal, obviously. So 5.00 into 10 to the power, how many digits we have taken? 2. Okay, so 2. All right, this is how it is converted. Now, as we can see, this is already in decimal. There is a decimal after one non-zero digit, which is 6. So it will become like 6.0012. But what about 10 to the power? If it is 1, then 10 is going to stay as it is. But what we have to do is, we have to give the power over here 0, because anything power 0 will be equal to 1. Okay, so that 10 powered 0 will be equal to 1. So this is how you are going to solve these kind of questions, where you have to give convert any number into scientific notations. All right, everyone, our next question is question number 19. How many significant figures? We have to calculate the significant figures present in the following. So there are few rules before doing significant figures. Okay, so let's talk about the rules for determining the number of significant figures, right? So first rule says that all the non-zero digits are significant. First one is that non-zero are significant, or zeros between non-zeros. Okay, there is a non-zero and then there is a zero, and then once again there is a non-zero digit. So these zero digits are also significant. All right. Next is 0 to the left of first non-zero digit in a number are not significant. Okay, like if I'll talk about 0.05, okay, then these zeros are on the left hand side. Okay, so these zeros are non-significant, whether 5 is significant, obviously. Okay, so this is another rule. This is third rule, that non-zeros to the left hand side will be non-significant. Okay, it can be, any decimal or anything. Okay, then there is another rule that if a number ends in zeros, but these zeros are to right of a decimal point, then these zeros will be significant. Okay, suppose I'm writing 200 decimal. Okay, is there is a decimal, or after decimal there is a zero. All right, so these all numbers, okay, which are up to decimal, they are significant. Okay, this is rule number 4. Fine. Or it can be written like this also, if you can say like 2.50, suppose this is like this, so this is also significant. Okay, this is also significant over here. Okay, right? If there is a decimal, okay, and there is a non-zero on the left and others are on the zeros are on the right hand side of the non-zero, then it is significant. These are this is rule number 1, this is rule number 2, this is 3, and this one is 4th, right? Then there is last rule. We can say that if a number ends in zeros, okay, but these zeros are not to the right of a decimal point, okay, so then these zeros may or may not be significant depending upon conditions. Now, how we are going to say it? Suppose you have a number. Suppose you have a number 5010500. Suppose, okay. So it may have 3 significant figures when we are going to calculate this one only. It may have 4 significant figures also. It may have 5 significant figures also, right? But how and where it will have 3 significant figures, where will it have 4 significant figures, and where will it have 5 significant figures? Okay, so suppose this number is written in the scientific form. Okay, suppose I will write it in the 1.05, okay, and 10 to the power 1 2 3 4. There are 4 decimals. Once again, decimal point is shifted to the left hand side. Previous question was like this, and to the 4 digits only. Okay, so then it will be 10 to the power 4. 4 will be positive. So if this is the case, okay, anything where 10 to the power is, any exponent is there, that is always going to be non-significant. Okay, all right. And if this number we consider only this number, then there is 1 2 3, there are 2 non-zero digits, and in between those 2 non-zero digits there is a 0. Okay, then this 0 is also significant. So there are 3 significant figures over there. Okay, once again we can write the same number in such a way also. Once again, this is a non-significant figure, right? But over here we have this 4th rule which is coming in between. Okay, to the right hand side of the decimal, it is going to be a significant figure. So 1, 2, 3, 4. Okay, it has 4 significant figures. Once again, the same number is written as 1.0500 because there were two zeros given over here, and 10 to the power 4. Once again, this is non-significant. This is always remaining non-significant. But over here, 1, 2, 3, 4, 5, 5 significant figures are there. Okay. And there is another rule, which is an additional rule. It is also given in your NCERT, that if a significant figure, okay, like you can write it down, suppose it is written 12 dozen. Okay. Okay, if this kind of number is written, then they will have infinite significant figures. Okay, they will have infinite significant figures. Okay, if it is written, you know, a certain number is written, and then after number there is certain thing is written, like you can write it down, 10 apples. Okay, once again, this is going to be infinite significant figures. Okay, 2 shoes, then that is also infinite significant figures. Okay, which means that if the name of a particular substance is coming after it, then it is going to be having infinite significant figures. All right. So now let's solve the question based on these rules. Okay, let's solve this question. Fine. This question will be based on all the 5 rules which we have done. If you find difficulty in doing this question, so you can go back into the video and then you can see what we have discussed about the rules. Okay, you can revert back and then you can come back to the question also. So let's go and solve it. Over here, this is the first question, that is 0.0025. Okay, so once again, these are 2 non-zero digits, and to the left hand side there are zeros. So these 3 zeros are non-significant, and only non-zero digits are significant. So there are 2 significant figures. Okay, now let's talk about the second one. Once again, 2 non-zero digits are there, and in between 2 non-zero digits there is 1 zero digit. So this 0 digit becomes a significant. So there are 3 significant figures. Once again, in the third question also, there are 2 non-zero digits, and in between 0 digits are there. Now once again, these are going to be significant figures. There are 4 significant figures. Let's talk about this question. Okay, remember that if there is no decimal, that means before, if non-zero digits are on left hand side and zeros are on the right hand side and there is no decimal, these zeros are considered as non-significant figures. So there are only 3 significant figures, which is 1, 2 and 6. Okay, let's go to this one. Okay, remember that I have taken the same kind of example, that 500 decimal 0. So this will have this 0 digits are going to be significant figures. Then there are 1, 2, 3 and 4 significant figures. Okay, now last one is, this is once again those non-zero digits and zeros are in between. So all are going to be significant. That is 1, 2, 3, 4, 5. There are 5 significant figures. So these rules are going to be helpful in calculating or in knowing that how many significant figures are there. All right, let's go to another question, that is round up the following up to 3 significant figures. Okay, we have already done that what are the rules to calculate the significant figures, and now we are going to round it up to the 3 significant figures. Okay, if we look at first question, there are 1 2 3 4 5 non-zero digits, and these are going to be 5 significant figures. Okay, when we round it up, first we are going to round up it directly. We know that if there is one number which is equal to 5 or more than 5, then 1 is added to the number which is on the left hand side of that digit. Okay, so that is going to be 34.22, right? But now this particular number has 4 significant figures, and we need a number with 3 significant figures. Now this 2 is less than 5, so we can omit it. Okay, and we can keep the 2 as such, which is on the left hand side of this second digit, that is 34.2. now there are 3 significant figures in this question, in this answer particularly, so this is how we are going to round it up. Okay, so let's go to the next one. Once again, we need only 3 significant figures, right? So we will count from the left hand side. This is a non-zero digit. Okay, there is a 0 digit, and there is once again a non-zero digit. This 0 will be significant. So 1 2 3, there are 3, we need only 3 significant figures, right? So we are going to take this number up to this, and 107 should be omitted. Then it is going to be 10.4, right? Now let's go to the third one. Okay, remember we have done that if there is a 0 to the right, not to the right, sorry, to the left hand side of the non-zero digit, then that is non-significant, so we are not going to count it. Okay, then we want 1 2 3, right? 3. But remember, we have to round up also, we have to round it up. Okay, then this particular number is greater than 5. So if that is the case, 1 should be added to the number which is on the left hand side, and it becomes 0.059 plus 1 is 60, so it's going to be 60. Okay, now if you will think about the rules very clearly, you will see there are 3 significant figures. How? 4 and 6 is significant because they are obviously non-zero figures. These are non-significant, so we are going to take them out of the context. But what about this 0? There was a rule, if you remember, that if there is a 0 to the right hand side of a decimal, that is a significant figure. So these 3 are significant figures. Okay, these 3 are significant figures. Now this is going to be the answer. Okay, so I hope this is understandable to all. All right, the last one will have it has only 1 2 3 4 significant figures. Now remember one thing, we have to round it up and we have to convert it into 3 significant figure number. Okay, so this number is greater than 5 once again. So what we'll do? 1 is added. No, 1 will not be added. If we add 1 over here, then this is not going to be correct, right? So what we are going to do, we are going to convert it into the next nearest 1 digit significant figure, which is 10. Okay, so that is going to be 10. 8 is converted to 0 and 0 is converted to 1. So it becomes 2810. Now over here you can see there are 3 non-zero digits, and this 0 is non-significant. Why? Because there is no decimal after it. So it will have 3 significant figures, which is 2, 8 and 1. So this is how you are going to round up any number into three significant figures, or obviously sometime it might be not be asked in three significant figures or four significant figures or two significant figures. These are the rules you are going to follow. Okay, let's start with today's next question. The following question is actually based on stoichiometry. So let's see different laws of proportion. You have done definite law of proportion, law of conservation of mass, law of multiple proportions, right? We are going to discuss them alongside, so don't worry. So this question is based on those laws. Okay, this question states that the following data are obtained when dinitrogen and dioxygen react together to form different compounds. Okay, so remember a law which based on same reactant, but if their ratios are changed, then different compounds were formed. That law was law of multiple proportion. Okay, so this law is multiple proportion. So we are going to talk about that law only. So there is mass of dinitrogen and mass of dioxygen has been given. The mass of dinitrogen in first case is 14 grams and dioxygen is 16 grams. Dinitrogen is 14 grams and dinitrogen in 32 grams in the next one. Dinitrogen in the third case is 28 grams and oxygen is 32 grams. And in fourth case, it is dinitrogen is 28 grams, whereas dioxygen is 80 grams. So obviously there are only two reactants, which is dinitrogen and dioxygen. Dinitrogen means N2 and dioxygen means O2. These gases, when they combine in different ratios, they form different products. In first, there might be some other product. We are going to discuss which one is that. And in second, there is another product. In third, there is another product. In fourth, there is another product. So 4 different products were formed, but only nitrogen and oxygen were taken. But there is one difference, that their masses are different. Okay, so let's see what are the questions based on this particular data which is given over here. So first question is, which law of chemical combination is obeyed by the above experimental data? So we have already discussed that this is law of multiple proportions. Okay, this is a law of multiple proportion, and law of multiple proportions says that when two elements combine to form two or more chemical compounds, okay, then the masses of one of the elements which combines with a fixed mass of other bear a simple ratio to another. Means, what is the meaning of it? There are two elements, they are combining into to form two or more different compounds. We can see it from here. They are going to form different chemical compounds. Then the masses of one element which combines to fixed ratio to another bears a simple ratio to one another. Okay, they are going to combine in fixed ratio by mass. That is the meaning of it. Okay, once again, in first case there will be one ratio, in second case there will be another ratio, in third case there will be another, and in fourth there will be another. So this is the law of chemical combination which is obeyed over here, right? This was the first question. Next is, fill in the blanks in the following conversions. All right, we have to convert these particular things. Okay, there are different things which have been given, like 1 kilometer is equal to how much millimeter, and 1 kilometer is equal to how much picometer, right? So we have to convert them. Okay, so let's go to that conversion one. Let's do first question. that is 1 kilometer is equal to dash millimeter, and which is equal to dash picometer. Okay, so let's convert first 1 kilometer into millimeter. Fine. So what we have to do, we should know that what is millimeter and what is the relation between kilometer and millimeter. So there is no direct relationship between millimeter and kilometer. What we have to do, we have to convert first 1 kilometer to meter, then meter to centimeter, and then centimeter to millimeter. What we are doing? We are taking different steps to convert kilometer into millimeter. First, kilometer to meter, then meter to centimeter, which is the smaller unit of meter, and then centimeter to millimeter, because millimeter is smaller than centimeter. Okay, because there are relationships between these. Okay, first of all, 1 kilometer is equal to 1000 meter. Fine. 1 meter is going to be equal to 100 centimeter. So 1000 meter will be equal to 100 multiplied by 1000. That is, the answer is going to be in centimeter. That is 1. There are how many zeros? 1, 2, 3, 4, 5. So 5 zeros are there. Okay, and centimeter. Fine. Obviously, this is equal to 1 kilometer. Fine. Now convert this centimeter into millimeter. Okay, should remember that 1 centimeter is equal to 10 millimeter. So if that is the case, then 10,000 not 10,000, there are 4, not 40, there are going to be 5 zeros, right? 5 zeros. So I did a little bit mistake over here. Okay, all right, so it's 1 lakh. Okay, 1 lakh centimeter is going to be 1 lakh. Okay, there are 5 zeros multiplied by 10. This is going to be equal to millimeter, which is, there are 6 zeros now. Okay, 6 zeros, millimeters. We can write it down into the exponential form, that is 10 raised to power 6 millimeter. So 1 kilometer is equal to 10 raised to power 6 millimeter. I hope this is clear to everyone. So let's convert 1 kilometer into picometer. Right? This is very easy. Okay. First, once again, 1 kilometer should be converted to meter and meter should be converted to picometer directly. Okay. So we know that 1 kilometer is equal to 1000 meter, and 1 picometer is equal to 10 raised to power negative 12 meter. All right. So if we convert that, you can take, in the other way also. So we are going to convert 1 kilometer is equal to 1000 meter. Okay, divided by 1 kilometer, right, multiplied by 1 kilometer, because we have to convert kilometer into picometer. Then 1 picometer should be in the numerator, and it should be divided by 10 raised to power negative 12 meter. Okay, this meter and meter cancels, kilometers and kilometer cancel, and this will go to the numerator, and if we take any denominator number to the numerator or numerator number to denominator, which is in exponential form, its exponential power sign is changed. So it is negative 12. Now it is going to convert into positive 12. That is 1000 multiplied by 10 raised to power 12 picometer. Okay, this is going to be 10 raised to power 15 picometer. So 1 kilometer is equal to 10 raised to power 15 picometer. So at the end the answer will be 1 kilometer is equal to 10 raised to power 6 millimeter and 10 raised to power 15 picometer. Okay, so this is how you are going to convert it. Now let's do the another one, which is 1 milligram is equal to how much kilogram is equal to how much nanogram. This is nanogram. Okay, so let's see that how we are going to convert it. So next question is, the second question is 1 milligram is equal to how many kilograms and which is equal to how many nanograms. So first we are going to convert 1 milligram into kilogram. 1 milligram into kilogram. Fine. So milligram is quite small value. Okay, and in between it we can first convert milligram to grams and then gram to kilogram, and we should know the relationship in between. All right, so let's take 1 milligram. 1 milligram is equal to 10 raised to power negative 3 grams. All right, and if I take 1 gram, then 1 gram is equal to 10 raised to power negative 3 kilogram. Fine. So if we take these values, okay, and it comes out to be 1 milligram is equal to 10 raised to power negative 3, okay, multiplied by 10 raised to power negative 3, which is in kilograms. That comes out to be 10 raised to power negative 6 kilogram. So this is how you are going to convert it. Next was 1 milligram to nanogram. Alright, so over here what we are going to do, we are going to once again convert milligram into gram and gram into nanogram, okay, like we did in the earlier part. So alright, let's take this 1 milligram is equal to 10 raised to power negative 3 gram, and 1 gram is equal to 10 raised to power 9 nanogram. Okay, as we know that nano means 10 raised to power negative 9. Okay, so that's how. So 1 milligram will be equal to 10 raised to power negative 3 multiplied by 10 raised to power 9, which is in nanograms, and this is equal to 10 raised to power 6 nanogram. Okay, so if we go and see the relation, 1 milligram is equal to 10 raised to power negative 6 kilogram and 10 raised to power 6 nanograms. Fine. Let's do the third last one. 1 milliliter is equal to how many liters and how many decimeter cubes. third question. 1 milliliter is equal to dash liter, which is equal to dash decimeter cube. So let's once again divide it into two parts. 1 milliliter to liter. It is a direct relationship. If I tell you 1 milliliter is equal to 10 raised to power negative 3 liter. Let me just rewrite this. Okay, this is a direct relationship because milli means 10 raised to power negative 3. Okay, you should remember it. Okay, now 1 milliliter to decimeter cube. Fine. First, we have to convert milliliter to centimeter. Okay, now I'll tell you a relationship that 1 milliliter is equal to 1 centimeter cube. Okay, now we can convert centimeter into decimeter. Fine. How we are going to convert? So 1 centimeter cube is actually 1 centimeter multiplied by 1 centimeter multiplied by 1 centimeter. Alright, and there is a relation between centimeter and decimeter. Actually 1 centimeter is equal to 10 raised to power negative 1 decimeter. So we are going to put this value over here, and 1 centimeter is equal to 10 raised to power negative 1 decimeter multiplied by 10 raised to power negative 1 decimeter, and which is once again multiplied to 10 raised to power negative 1 decimeter. So once again it becomes equal to 10 raised to power negative 3 decimeter cube. So 1 milliliter is equal to 10 raised to power negative 3 decimeter cube. So this is how milliliter is converted to liters and decimeter squares or cubes, sorry. So the answer will be 1 milliliter is equal to 10 raised to power negative 3 liter and 10 raised to power negative 3 decimeter cube. So this is how you are going to convert 1 unit of a particular physical value to another. These are going to be very helpful when you are going to do various numericals. So that's why they have these kind of questions been included in the syllabus. I hope you have enjoyed today's session. Thank you so much. Have a nice day.